How to write final answers to polynomial division problem. Okay, let's divide 37 by 5 to build up our intuition. Long division will give us a quotient of 7 and a remainder of 2. So how do we write the answer? We can say 7 little r 2. 7 for the quotient, 2 for the remainder. Or equivalently, you can say quotient equals 7, remainder equals 2, which is how Alex does it. Or the familiar mixed numeral format. We can say 7 and 2/5. 2 is the remainder, 5 is the divisor. Now we can write two equivalent equations from this division process, which we can use to check our answer. The first is the quotient remainder form, which is actually a reversal of the division process. We say 37, the dividend, equals 5, the divisor, times the quotient, plus 2, the remainder. The second is the fraction form of the division process. 37 divided by 5 can be expressed as a fraction, 37 over 5. And this will give us the mixed numeral form, 7 and 2/5. Remember, we can check the answer. We can reverse the process by using the mixed numeral format. We multiply 7 by 5 and add 2. So that gives us 35 plus 2 equal to 37, which was the dividend. So notice that what we just did is equivalent to the quotient remainder form. Now let's go to polynomials. Let's divide the polynomial 2x cubed plus 16x squared plus 10 by x plus 8. Notice that the power term x to the 1 is missing. So the solution by long division is this. Note that I replaced the x1 term by 0. In general, you do this for every missing power term. Replace it by 0 before doing the actual division. So the quotient is 2x squared plus 0x, and the remainder is 10. So we write the answer as 2x squared, remainder 10. If we do synthetic division, we will get the same thing. Note again how I replace the missing power term by a 0. I will get the same answer, 2x squared, remainder 10. It is not correct to write 2x squared plus 10 as the result of the division. The valid ways of writing the answer to a polynomial division problem are as follows. You can use the quotient remainder form, which is 2x squared remainder 10, or 2x squared little r 10. Or you can write them separately. Quotient is 2x squared, remainder is 10, but you do not add them. So for the division check, we write the original dividend polynomial, 2x squared plus 16x squared plus 10, and that should be equal to the divisor x plus 8 times the quotient 2x squared plus the remainder 10. Now in fraction form, we will express the division as a fraction. 2x cubed plus 16x squared plus 10 divided by x plus 8 is equal to the quotient 2x squared plus a fraction 10, the remainder, over the divisor x plus 8. This is similar to 37 divided by 5, and we got 7 and 2/5. 7 is like the quotient, and 2 is the remainder, 5 is the x plus 8. This is what will happen when we multiply both sides of the fraction form by x plus 8. So x plus 8 times x plus 8, this will cancel. Here, I'm going to distribute the x plus to both terms, and this will result in the cancellation of that x plus 8, which gives me therefore, never add the remainder to the quotient. The two are separate expressions related only by either of these forms. The quotient remainder form of division, which is the polynomial equal to the divisor times the quotient plus the remainder. That's the only place where you can add the remainder. Fraction form of the division, polynomial over divisor equals the quotient plus remainder over the divisor. So in either form, we do not add the remainder to the quotient, not at all. Now in the test, we will just use whatever the format that Alex asked from you, which is to write them separately. You write the quotient and you write the remainder as separate expressions.